Hi, all. So in the last class, we were actually discussing about the big O notation, the different ways in which I can have the big O notation. So this concept actually when is coming when we were actually having the concept of this one, what asymptotic. Okay. Yeah. So we have already completed the three types of time complexity notation, or the way how we will be depicting the time complexity, that is linear time complexity, then we have quadratic time complexity, and then we had logarithmic time complexity. Okay, also we have seen which examples will be considered for each of the what a complexity, like if we do what kind of task, or in order to solve a particular problem, which solving which kind of problem will actually give us what type of complexity, and how we are going to describe in terms of the big O notation. Okay, now the fourth type is cubic time complexity, which is nothing but O of n cube. So quadratic we have seen, which is O of n square. Now for the cubic we have O of n cube. Okay, so now we'll see what type of operations, okay, within a input. For an input, if we perform what kind of operations, we are actually getting the time complexity of cube. Okay, that is n cube, like cubic time complexity. So we'll first of all see the analogy for which the cubic time complexity is well suited. So imagine a school has three sections, okay, and they are A, B, and C, and they want to pair every student. A, B, C is there. They want to pair every students in the each sections. Total three sections are there, and if we say each student in section A must meet every student in section B, and then every student in section C, so we have to make the pair there. Means from the three sections, I want to make a pair. So that pairing can be done from each student from A going to B, or can be from A going to C. And now you understand the complexity of it. So if each has 10 students, what we have to do? These 10 students will be meeting the 10 students with the B section students, and the 10 students with the C section students. The total 10 into 10 into 10 operations are going to happen, which is total of 1000 operations. Got it? So my number of inputs are 10, but I have three sections. If I'm actually to meet these 10 peoples of 10 different, I mean three different sections, then it would be 10 into 10 into 10, 10,000 operations, because there are 10 students. From the 10 students, each one of the student will be meeting the 10 students of his class also. Okay, and then they will be meeting 10 of B also, 10 of C also. So that's one of the example which will give us the n cube time complexity. And now next we will see a particular example which is giving us n cube operation. So multiplying two matrices, when I multiply two matrices, I'm actually getting cube operation. That is, each cell in the result matrix is formed by multiplying entire rows and entire column. Correct? So in the result matrix, to get each and every element, we are multiplying entire rows and entire column in order to get, then we add it also. Correct? So we'll see that operation, how exactly the multiplication of matrix is happening. Then we can get to know how exactly n cube is happening. Okay. Yeah. So here we have the example, that is naive matrix multiplication. So here if we consider, okay, in order to multiply a matrix, we need three for loops. So I don't know if you remember, I have once told that how to identify in a particular given implementation of algorithm, easily how can you find the complexity. So if here I have three for loops, so I can give it as n cube. In case if I have one for loop, I can give it as n. In case if I have two for loops, I can make it as n square. The reason is because n two for loop means in my array, if I have 10 elements, once I'll be doing the iteration for all those 10 elements. Then again, if I want to make some operations on each of one elements, then I'll be making use of one more extra for loop. That is how the n square operation is happening. But here we need one more extra thing, which is n cube. So let's just see how matrix multiplication is working. Then we will get to know why that extra k for loop is needed for us. Okay, why not we can just limit the multiplication of matrix with two for loops. Let's see. So suppose if I take two matrix, okay, so we'll do one thing. Let me share. Okay. So I hope the cloud, sorry, the whiteboard is visible to you, which I have shared. Okay. So now here, let me show you how exactly the what the matrix multiplication is taking place. Okay. So now, for example, if I have two matrices, we will take the 3 by 3 matrix. Here I have some elements. Okay, I will take 1, 2, 3, 4, 5, 6, 7, 8, and 9. I'm taking this one particular example. And I'll be multiplying it with 1, 2, 3, 2, 1, 3, 2, 2, 1. Okay. So let's have this as our matrix. Let me erase this and put it as 1 here. Okay, now, in normal way or rather than it is computing in a system, how we are going to trace out the matrix multiplication is, first what we are going to do is, if I, okay, we'll just have the resultant matrix here. So the resultant matrix, if I say, we all know that these is row 1, row 2, and row 3, and this is column 1, column 2, and column 3. Okay. Now, in the matrix, if I say I'll be doing, if I write 1 by 2 matrix, it is nothing but I have 1 rows and 2 columns. Now, what is our matrix here? 3 by 3 matrix, which is nothing but I have 3 rows and 3 columns. Okay. Yeah. Now, what we are trying to find here is, this would be first row, first element, correct? First row, second element, and first row, third element. So this would be second row, first element. This is second row, second element, and this is second row, third element. Next one would be third row, first element, third row, second element, and third row, third element. Now here, I want to find the first row, first element. So we know that always rows comes first and column comes next. In order to get the first row, first element, we will be multiplying each elements of first row of first matrix with first column of first matrix. Okay. So note down that if I want in the matrix first row's first element, I will be going with first row of first matrix with second row of second matrix. Sorry, first column of second matrix. So in second matrix, we only just see the column. In the first matrix, we only just see the rows. That is the idea. If I want to get first row, second column, then nothing but same we will be doing. First row, and we will be doing multiplication on second row. Now let's see one example. Let's take this one. Okay, third row, second column. So how would be the calculation? This is my third row, second column. So now let's multiply it. I want third row, second column. In order to get third row, second column in matrix, we have to divide the corresponding elements. So this is the first element. So I have to multiply the corresponding first element of that column. So 7 into 2 is plus 8 into 1 plus 9 into 2. So 7 into 2 is 14 plus 8 into 1 is 8 and 9 into 2 are 9 2s are 18. Okay. Yeah. So now what is 14 plus 8 plus 18? So 14 plus 8 gives us 22. 22 plus 18 will give us 40. Okay. So altogether we are having the value as 40. So what is the value after multiplying this with this? The third row, second column value would be nothing but that is 40. Okay. So this is how each and every element in matrix are calculated. Now let's come. How exactly in the for loop, what happens to the uh, what matrix, or how calculation matrix multiplication is going to happen in our code in terms of algorithm. So let's see. Let me show. Okay. So in the code, it gives us, or what it gives us in the code, public static word multiply, int of matrix 2 and int of result, because it is a 2 by 2 matrix. Okay. Sorry, not 2 by 2 matrix. It is giving us the dimensions. We are working with the matrix, right? So we need 2 dimension. Now for int I equal to 0, I less than n and I plus plus. Okay. For int j equal to 0, j less than n and j plus plus. For that, I have to make my result of ij is equal to 0. Now next what we are doing is, for int k equal to 0, k less than n, k plus plus. Some random value k I am going to take, and for each k values, we are going to multiply it. Okay, multiply the two values, and then we will be adding the values, and finally we will be getting the value, and that will be stored in my result of ij. So how here the thing will work is, we'll trace down. So earlier I had some two-dimensional data, that is matrix, and which will give us the resultant matrix. Now, as I've told you, if I want to get the element here, which is first row, first column, I have to multiply first row of first matrix into first column of second matrix, because row and column we are seeing first matrix for row and second matrix for column. Okay. Now let's go through the code. For I equal to 0, I less than I plus plus. Okay. Now I'm going to, what is my I? I is nothing but my row, and j is nothing but my column. So right now my I is 0. So now we know that in matrix computers, the first row we don't say, the index start from 0 1 2, correct? So here 0 1 2, and here also 0 1 2 I have. Now my row part I will be seeing my first row, which is 0, and j equal to 0. Now j is also equal to 0. So that is my first row. Now we will come to this. Int k equal to 0, k less than n, and k plus plus. Now, matrix of 1. From this first matrix, what is my I value now? 0. What is my j value now? 0. Okay, so you can clearly see that this is matrix 1. So from the matrix 1, I comma k. Now my k is also 0. Correct? My k is also 0. So I comma k, which is nothing but my 0 comma 0 element into my 0 comma 0 element from the second matrix. So my 0 comma 0 element from first matrix into my 0 comma 0 element of the second matrix, I will be multiplying first. That multiplied value I will be adding to my result of ij. So some random value will be stored. In our case, it was I think 1 into 7. 7 into 2. I got the value as 14. Correct? Okay. So I stored it. Now I will be in the same row and same column, but I have to shift to the second one. That is, I will be in the 0th row itself, but I have to move to the second column. So that column is nothing but my k now. In this case, k is nothing but my column. So k value will be incremented. So k value will become 1. So now when k value becomes 1, 0, 1, which is nothing but my second value. Yeah, which is nothing but my second value. And here also the same thing will happen. Okay, now if you clearly see the code, where is the code? If we see the code, you can see here for for matrix 1 we use I variable, and for matrix 2 we are using j variable along with the k variable. So this element of second one, that is nothing but your 0th I value and k value 1 and 0th j value. Now we are in 0th j value itself, that is column itself. 0th j value plus into this variable into this one. Now my k's value has become 1. So I have to move from here to here, here to here. So two variable I want, which is I and j for rows and columns mapping, and k value I want within each row and each column. I want to iterate through the value. So for that I need to keep track of the k. So finally what will happen? I'll be getting a combined value, which is r es of I comma j, which we will be storing it as res of I comma j itself, because my I comma j is not at all going to change. That is 0 comma 0 itself. Only k values are changing. So in your result matrix, your 0 comma 0 is nothing but this one. So at the end, it will be storing the value. Now after this k value completes, that is n means nothing but in one row how many elements are there. So when the k value reaches the value n, it will be coming here and incrementation will happen for I value. And okay, first the incrementation will happen for j value, correct? Then it will go for the I value. So in your every column, it will see for all the values, and then it will go for the outer format. So this is how the matrix calculation will happen. That is why we need three variables in order to maintain, and third order operation is happening while calculating or while multiplying the matrix. So the time complexity would be depicted as O of n cube. So these nested loops, each running n times. Okay, each running n times. So that is why the operation would be n into n, which is n cube, and that is nothing but the, according to the big O notation, we will be giving it as O of n cube. Okay. Yes. So the best case and worst case is same. Okay, the minimum best case what it can have is n cube. So it will always runs in O of n cube. So no optimization is needed, as other what algorithm which we are writing like linear and binary search. So now if the value of the n is doubling, then the runtime becomes 8 into larger. Means, for example, if I have C, it will take the simple example. If I have two inputs, okay, the value of n is 2. 2 raised to 3 is nothing but 8. Now, if I say I have three inputs, what is the value for three inputs? So 3 threes are 3 raised to 3 it will become. So 3 threes are 9. 9 into 3 is 27. So 8 times larger this value will become when I compare it with the 2. Okay. So, sorry, we have to say when the number of n doubles, right? So that would become 4 cube. So 4 cube means 4 into 4 is 16. 16 into 4 is some values we'll be getting, correct? 16 into 4, that is nothing but 4 6 are 24, then 4 ones are 4, 5, 6. So 8 times we will be getting 8 times large. That means what? 8 into 8 is giving us 64, correct? So when the value was 2 and when the value doubled, that input value doubled to 4, we will be getting 64. The unit time will take 64. So if it takes 64, which is nothing but if I double the input value, then it will become 8 into 8 times larger. It will become. Okay. Yeah. So that is how the time will drastically increase when I say cubic time complexity. Yeah. So that is about the cubic time complexity which we are having. Next, we will see exponential time complexity. So, but here, as the name indicates, in cubic we are having O of cube. Sorry, big O notation of n cube. But in this one, exponential time complexity, we will be having like the power of 2. Okay, the power value would be whatever the number of inputs you are having. So 2 raised to n it is. It is exponential time complexity. We'll see what will be the analogy for this. So imagine choosing a team captain and vice captain from a group. So we can either include or exclude each student. And if there are n students, there are 2 raised to n ways to form the teams, correct? Now, for example, if I have, let's have some symbols. Okay, let me have some symbols called as blue, red, and green. Okay, now I have three, let's say that 3 people are there. I want to form a team like that. Okay, so I can have how many inputs I have now here? I have 3 inputs. Now, a team of 2, if I'm saying you form a team of 2, then how can I form? So either I can go with B and R, either I can go with B and G, either I can go with R and B, either I can go with R and G, either I can go with G and B. So G and B is already there. Okay. Okay. So leave it. So G and B, if the order doesn't matter, we will go with that. So if G and B are there and if R, G and R is there. Okay. So we will be getting 2 raised to 3, which is nothing but here we get us only 6. Okay. So this is not the case. We need to get further other elements. Okay. Let's see with the other example. If I want to generate all the subsets of a set, so okay, I hope you know what is the set theory. And if I want to get all the subsets of the set, we have the same, what we call it as a power set of set, and we have the same formula. What happens there is every element has the 2 choices, whether whether should include it or not. And what will happen is this will be doubling each, the possibilities each time. Now, for example, if I say I have the value 2 raised to 2, and I'll say 2 raised to 3, and I'll say 2 raised to 4. So what is the value of 2 raised to 2, which is 4? What is the value of 2 raised to 3? It will be 8. What is the value of 2 raised to 4? It would be 16. Now, if you see, if I double 4, I'll get 8. If I double 8, I'll get 16. So each possibility, this doubles the possibilities each time. As your value increases one after the another, exponential growth will happen to your time complexity. Okay, that is why the name and the equation goes hand in hand. 2 raised to n means it is considered as exponential time complexity, where n is nothing but the amount of input you are having. We have a beautiful example for exponential time complexity, that is O of 2 raised to n. Okay, means every time here I will be having two of them with me. For each means for each iteration, I'll be having two components to look after. So this is actually happening with the Fibonacci, that is recursive Fibonacci is going to happen. Okay, so let's see this one. I hope we know that what is Fibonacci series. Okay, so if I have a number 0 and 1 which is set term, now I want to write the Fibonacci numbers of 5 numbers. Means what? No, I'll be adding a number with the previous number and I'll be getting the third number. Okay, so if I want the five numbers of Fibonacci series, so 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5. So this is the Fibonacci of numbers. How many place values we are having here is 6. So Fibonacci up to the number 6. Okay. Now we are having one code there. So the finding the Fibonacci of numbers is actually coming with the power of 2 raised to n. And here we are having each time we'll be seeing the two numbers. We'll be adding the two numbers. Okay, we are having one simpler code here. We'll take an example and we'll trace it out. Public static int of Fibonacci of int n. If n is less than or equal to 1, I have to return n. That means for the Fibonacci, if I say I want this many amount of terms in my Fibonacci series, that is nothing but your n. Now, if I give less than 1, okay, or equal to 1, I will be returning the n itself. So if I'll say I want Fibonacci of one term, so that's not possible for me. Okay, so Fibonacci of the first term, I'll be getting it as 1 itself if I take 0 and 1 as a fixed numbers. Okay, yeah. So whenever your value of n given by the user is less than or equal to 1, I'll be returning that number itself. Okay, and then we'll be calculating. If I'll say, for example, if I'm saying that I want the Fibonacci series of 5 terms, so we will take it. So Fibonacci of n minus 1 plus Fibonacci of n minus 2. Okay, then what we'll be doing is, for again we are recursively calling it. Okay, so if I give one number, it will be dividing it to two number and it will be adding them. Now again, Fibonacci is nothing but a function, correct? So again, the function call will call to here. And when that function is called, again it will divide it into two parts, two equal parts. So this is how the things is getting here 2 raised to n. So if we just trace it out, if we take some value, n is equal to 5, we'll see what exactly we are getting. So now suppose n is equal to 5 we are having. Okay. As soon as I give the value 5 to my Fibonacci function, what should happen? I have to get a function, that is the first I will be writing fib of, okay, fib of 5. So fib of 5 is nothing but, let me change the place from here. So I'll be writing here fib of 5. So fib of 5 can be divided as 2. What is that? Fib of, what is 5 minus 1? 4. Okay. And what is 5 minus, what is 5 minus 2? Sorry. Yes, 5 and n value is 5. So 5 minus 2 is fib of 3. Now fib is again a function which will divide further into 2, 2, 2. Correct? Until and unless the values become 0 and 1. So when n equal to 0 or n equal to 1, we'll be sending the value as 1 and 0 itself. If n equal to 0, I'll be sending the n value itself. If n equal to 1, then I'll be sending the 1 value itself. Okay, so that is we have given. If n is less than or equal to 1, we are sending the value directly. Okay, so now here I will be dividing. If I say fib of 5, I'll be dividing it into 2. Now again, fib of 4 can be divided into 2. How? 4 minus 1 is fib of 3. So here I have to add, okay. So fib of 3 plus here it will be 4 minus 2 is equal to fib of 2. Now again I'll be having fib of 3 here. So let's divide it. That is 3 minus 1 would be fib of 2 and 3 minus 2 would be fib of 1. Now again further we will divide it. So in the fib of 3 again we will get that is fib of 3 minus 1 is 2 and here I'll get fib of 3 minus 2 is 1. So that is fib of 1. For fib of 2, what I'll get? 2 minus 1 is nothing but fib of 1 and this is nothing but fib of 0. Again, here also the same thing will get. So here the addition is there because the code is giving like that. So for this fib of 2, we have fib of 1 plus fib of 0. Okay. Now again, this can be divided. Fib of 1. How can I divide fib of 1? Should I divide it? Fib of 1 would be fib of 1 minus 1, that is 0, and fib of 1 minus 2 will become minus 1. So we don't want that, okay, as it gives us the negative number. So we'll just go with this only up to fib of 0 and fib of 1 will take, because fib of 0 will take it as 0, fib of 1 will take it as 1. Okay. So now what we'll see is, we'll calculate. Now further, where is, did we come to the end? No, we further have fib of 2. So here, if I consider this fib of 2, it will give us fib of 1 and fib of 0. Now we will check in each level what value is given for us. So in the first level, as we see, in the first level, it will be 0 plus 1. It is 1. Okay. I will consider that as 1. And so what is this fib of 2 value? We are getting it as 1. Okay, so we need to be very careful on this. Fib of 1 is 1 and fib of 0 is 0. So 0 plus 1 would be 1. And now this value is 1. So what is fib of 1? 1. So 1 plus 1 is 2. Okay, so hope that now fib of 3 become 2. Okay, and then here what value we are having? Fib of 1 plus fib of 0, which is nothing but 1. So here the fib of 2 becomes 1. And here what is fib of 1? Here it becomes fib of 1 and fib of 0. So that is nothing but again fib of 1 plus fib of 0 is how much? Which is again it is 1. So fib of 2, the value of fib of 2 is always 1 we are getting. And then here we are having fib of 1, which will consider it as 1 itself. Now if I see here, I'll be getting in this way, I'll getting 2 plus 1 is equal to 3, which is nothing but my fib of 4 is equal to 3. And then we will get next is 1 plus 1, which is nothing but 2. Okay. And next we will get 3 plus 2 is equal to 5. Now, if you see, we'll be getting this one pattern wherein first I'll be adding 0, then 1, then 0, 1, 1 is 1, then 1 plus 1 is 2. Here we get 2. Okay, then what we will get is 2 plus 1 is equal to 3. Okay, then we will get 3 plus 2. Okay, this 3 plus 2 we will get. So 3 plus 2 is equal to, at the get the 5. Okay, so Just give me a second. So this division has happened. Okay, with the recursive, the division has happened. Here we consider fib of 1 and fib of 0 as 1 and 0 itself. So here 1 and 0. Now here there is one small plus for me. Fib of 1 is 1 and fib of 0 is 0 I am considering. Okay, so 1 plus 0 is 1 itself. So this 1 plus 0 is 1 is nothing but we are solving for the fib of 2. Okay, so now the value of fib of 2 is 1. We know already fib of 1 is 1. Okay, so 1 plus 1 would become 2. Okay, now we'll come solving this part. So fib of 1 is 1 and fib of 0 is 0. So 1 plus 0 is 1. So this fib of 2 will be giving us the value as 1. Now we got this 2 plus 1. Now we will add 2 plus 1 is how much? 3. So fib of 4 is nothing but we're getting the value as 3. Now we'll come solve this side. So fib of 1 and fib of 0 is 1 and 0 itself. So 1 and 0 is nothing but 1. So my fib of 2, always my value would be 1. Next, what I will be getting is fib of 1, which is nothing but 1 itself. So 1 plus 1 is nothing but how much? 2. So fib of 3, earlier also we got fib of 3's value is nothing but 2. So we'll be getting the value as 2. Now we will add 3 plus 2 is nothing but fib of 5. So we will be getting all the values. That is, first we have 0 and 1. Then from the 0 and 1, we will be getting 1. Then we will be getting the 2. Okay, that is 1 plus 1 is 2. Then we will be getting 3 here, which is nothing but 2 plus 1 is 3. Then again in the end, we will be getting 5. So this is how the Fibonacci series will be happening. But here, what is our responsibility is to find how the division occurs each time. So in each iteration, everything will be divided into 2 branches. That is why 2 raised to n. So till how many depth we have gone? We have gone up to 5 levels, but each time there are two divisions. So here we can see 2 divisions are there. Now for this each 2 division, we have further 2 division. For each these further 2 divisions, we have further 2 divisions. Okay. So what we are having here is the value will go up to 2 raised to n. So how much input you are having, depending upon that, it will go on increasing twice the amount. Okay. So twice the amount, we have seen that how double it will become. Like for example, if I take this example, which is 2 raised to 2, 2 raised to 3. I have explained this, right? 2 raised to 4. 2 raised to 2 is nothing but 4. 2 raised to 3 is nothing but 8. And 2 raised to 4 is nothing but 16. So what are these values? 4 plus 4 is 8 and 8 plus 8 are 16. So that exponential growth will happen to that particular values whenever I have a particular number of inputs. So if my input is just increasing by 1, okay, if I have I had 2 inputs, and when I go to the third input, the time taken for that would be very complex, because for each input we are taking twice the amount of time in order to calculate the problems. Okay, so that is why the base case is given here 0 of 1, which is nothing but when the value of n is 0 and when value of n is 1, because f of 0 will be considering, that is Fibonacci of 0 will be considering as 0 and 1 is considering it as 1. Now, when we are getting the n value is very large, then worst case scenario would be of 2 raised to n. And when we have n is equal to 40, which is something to approximate to 1024 calls, like 2 raised to 10 operations kind of will be taking place. So that is how exponentially the time complexity will grow when we have this kind of algorithm. Okay, so for each time the things are dividing into 2, double, it will happen. Okay. So the next what we have is factorial time complexity. So I hope we all know how to calculate the factorial. Like if I have 5 factorial, if I say 5 factorial, then we'll be multiplying how? 5 into 4 into 3 into 2 into 1. We'll be multiplying the number by its like by the adding to the previous number or by subtracting 1 from the previous number, correct? So if I have 5, then I will be subtracting 1 from that, which should be 4. Then its resultant will be multiplied with its minus 1, that is 3, then into 2, then into 1. If I have 10 factorial, I'll be giving 10 into, then I'll be giving. So it would be a very big number if I say 10 factorial. Let's keep it with 5 factorial. So it would be 5 into 4 into 3 into 2 into 1, which is nothing but 120 possible ways. Okay. So if I say 5 factorial, so if I have 5 elements in which the factorial kind of operations are taking place, okay, then the time complexity we are depicting it by using 5 factorial because that many operations are going to take in order to complete it. So here one example is there, generating all the possible seat arrangements. If there are n people, we try every possible order. Okay, that is one of the analogy for factorial time complexity and example for the time complexity. Okay, so we actually have a part of code, which is given in the next slide. Okay, so wherein we are going to use the permutation. Okay, like if a number is given, how the backtracking, everything is happening, how the recursive tree will be created for n factorial function calls. So as we can see here, if the value of n is equal to 10, this is nothing but we'll be getting these many big permutations. So that many combinations of what operations are taking place. So for us here, even the best case and also the worst case would be n factorial, and there is no easy optimization for this. So when we will get such kind of time complexities, whenever we're having huge amount of data and we have to perform huge number of calculations on a particular input of data, then we will be getting it will take too much amount of time. So that can be depicted by using this n factorial method. Okay, so that's all about the different types of what big O notation we are seeing. Okay, so depending upon the best case and worst case, we'll be using the notation. We have learned that, and the five to six types of time complexity we have seen, including linear time complexity, logarithmic time complexity, then cubic time complexity, quadratic time complexity, and today we have seen factorial time complexity, and one more is exponential time complexity. Okay, yeah. So here we may just conclude the asymptotic analysis, okay, where we have learned how to analyze a given algorithm and how to write it in terms of the complexity by taking its function and checking its growth of rate. Okay, like how they are growing in terms of your number of input is increasing. Okay, yes, that is nothing but n log n, right? Okay, polynomial is nothing but when you have, so see now, for example, if I have n square, that's nothing but when I have two for loops. If I have n cube, it is cubic we are calling. When I have n raised to 4 and n raised to 5, we consider it as polynomial. So multiple numbers are there as a power of n. Okay, so then it becomes polynomial. And we have one more notation which we write something like this, n log n. Okay, wherein we combine the normal O of n and also the log of n. When your what algorithm is having these both it is having, so we combine that together and we'll be mentioning the time complexity as n log n. Okay, yeah. So that's all about the time complexity and asymptotic notation, asymptotic analysis, and that's all about algorithm. But in the coming classes, once after we learn about yeah, so once after we learn about data structures completely, like different operations on it, the algorithms we'll be using in order to insert, delete, update the things in each data structures. Okay, so after that we will be completely learning about algorithms. So as we have seen, there are many different algorithms, many different approaches are there, like greedy algorithm and all. So how we can implement it by taking some example, all those things we are seeing when we are discussing about the algorithm. Okay. Yeah. So for the next class, we will start with the data structures, starting with arrays. Okay. So arrays is nothing but one of the linear data structures, which is also a static data structure. In arrays, what are the different things we are having, and what are the operations performed on that particular data structures? How is the algorithm written for it in order to perform those basic operations, traversal of arrays, insertion of elements, deletion, all those things we'll be learning in the next class. That's all for today. Thank you.